Welcome back, folks, to FinTech Festival India's Bengaluru Micro Experience. Now, we are joined by Mr. Shashank Bhaskar, AVP Engineering with Nucleus Software. Mr. Shashank is here with us today to give an innovation talk about AI and ML for FinTechs. So, Mr. Shashank, the stage is all yours. Over to you.
So it is a privilege to be here at FinTech Festival, and my talk is on the natural language processing. So when we move into the world of artificial intelligence, it is driven by a very conceptual framework of data, and that is proposed by Stanford academians, and it says the great product attracts users, and definitely it generates the data, and eventually that data improves the great product. So that's the virtuous cycle of data. A very noble thought, and if we let's extend this thought to the world where we are surrounded by the text, and text is everywhere. Text has fact embedded into it. It is the integral part of our life, and we need smart machines to extract text, and by doing so, it will enable businesses to have intelligence, business strategies, more insightful, or by going through the various messages all across the internet, on social media, we can prevent threats. Or for that matter, any customer who is looking for a loan from a particular bank and submitted the document, so that can be used as a fact checking as well for the documents as well. So text is like everywhere, but this text is all in unstructured form. So we need a common approach wherein we should be able to, for the machines to understand it properly. And that's where the NLP comes into play. And as I mentioned, machines can be helpful. And for that, this text which is there is in our language. And first, machines need to understand our language, and of course, then learn the language. Let's first have a brief understanding on what is the context or the organization of our language. The basic construct, it has words, sentences which are formed by words, and then there is a paragraph or a dialogue or discourse, again formed by multiple sentences. And each of these constructs are actually deriving the meaning, that paragraph is exhibiting an idea which somebody wants to share. So there's a meaning attached to that. So is the word which we require for. And let's extend this thought further. While you look at that, language is pretty simple, but for humans, definitely it is simple. Let's take this simple communication which has been sent by the financial institute to a particular customer, and as very simply, it looks like it has two sections. First is the mode, what is the purpose of that communication, and it has got the details as well. And for any financial institute's officer or for the borrower, it is pretty easy to understand that there is something called there is some information which is required in terms of a reminder which is going. So there's a context for that. There is a payment which has been defaulted, and as a human, we are able to understand it very easily. And when I say human, again, subject matter expert, they are able to understand it easily and arrive and intelligently drive that data point out of that. But we know that machines don't understand text as such. Machines only knows the number, and which is binary form basically. And what if we have some mechanism wherein we can convert, we can have this text in some form of number, and I think then something can be done. This is something based on the distribution hypothesis, which is based on something called semantic theory. Distribution hypothesis is all about having quantifying and categorization of semantic similarities of in the underlying linguistic expression or a word in a large language data I'm talking about across the distribution properties. Now, this distribution hypothesis, in a simpler form, it is all about arriving at the meaning of a particular underlying linguistic expression or word in a given corpus of a text. This hypothesis is based on the semantic theory, as I mentioned, And semantic theory is what is derived from this particular quote from famous British linguistic Robert Firth. And it says, "You shall know a word by the company it keeps." And when I mean shall know word, it is all about arriving at the meaning of the word from the words around that. That gives the way how basis of that. Let's extend this thought and see how machines are able to arrive at. These are sample few words, and what you see on the top are the 7 different kind of a distributional properties. So each, for example, these properties are living being, feline, human, gender, so on and so forth. And there are some scores given to that. Now the scores are between -1 to +1, and the higher the score, which means it is near to the positive, the numerical value 1, the more the association of that particular word is for that particular property. And this is a 7-dimensional vector, what you say, and each word is given some score. And we'll worry about how the score is given, but these scores are arrived at with some technique. Now, if we transfer this 7-dimensional vector, pretty difficult to visualize, into the 2-dimensional form, what you see on the right-hand side is, cat and kitten are the 2 words which are very near to each other. And the distance, when I say distance, the Euclidean distance between these 2 is smaller as compared to any other word within that group. So let's extend this further. How by taking another example, and a very famous example here, again projecting these 4 words, man, women, king, queen, and projecting into the 2-dimensional space. What you see, the distance between man and women and the king and queen are same. Again, the Euclidean distance. And if you perform a pure arithmetic operation on that, on these vectors, and I say king minus man plus women, what you arrive as an output will be the coordinates or the vector which will be very near to the what you see in the queen. And this is the something, and by doing that, now we are able to see the machines are able to identify these semantic similarities. And that's the fundamental block for the natural language processing. And what you see in the middle is called the embedding, or the word embedding. Having said that, this language is still complex. It is evolving. Humans are evolving. And there's a huge amount of ambiguity in the language as well. So it is even difficult, it needs to be further handled how such complexities are taken care of. And what you see as a perspective, Google has not been our as a verb in our dictionary maybe 15 years back, but and so is the case. We are not interacting in the Shakespeare style sonnets. So language is evolving. Why? Because the humans are evolving. The order of words is important. So probably the word embedding, what we understood in our previous slide, may not be sufficient enough to arrive at these complexities. So, and let's take another example. There are 2 different sentences, and we have used the word books here, and apparently the pronunciation is same. But as a human, we are able to distinguish them. But how the machines will be able to distinguish, because they have altogether inferring to the different meanings altogether. And that's where there has been a lot of progress which is happening in this space, and state of arts are getting innovated. And that's there's another famous architecture which is called Elmo, which helps in the complexity that we have seen in our previous example. It is a deep contextualized word representation, which means it is deep because there's a deep neural network which has been used, contextualized. Why it is contextualized? Because now we need to take that word in particular context, and then we wanted to have enhanced embeddings out of that. And it is done by basically it's a LSTM network which is bidirectional. And first, this sentence, this particular each word for each word, there is a character embeddings are generated, which means even the characters, which are alphabets, which have been in a particular word, those are also been considered in terms of generating an embedding, enhanced embeddings, and these are passed to this by LSTM network, which I mentioned. It's forward going and forward propagated and then back propagated. So by doing so, we can predict the future word based on the current, as well as we can predict the previous word based on the future word. So this helps in generating enhanced embeddings, which helps in deriving a meaning out of that. As I mentioned, there has been a great innovation happening in this field, and I also mentioned that the language is evolving. So is this. The architectures are also getting into action. We talked about embeddings. We talked about Elmo, and then there is a path-breaking change, which is a transformer-based architecture. It was basically based on some attention-based model, which eventually it has fundamentally two blocks, which is something called encoder and decoder block. And the beauty of this particular architecture is that we can take individual blocks and arrive at a different architecture, which can further strengthen the outcomes of a particular NLP task. If we take the stack of these decoder blocks, we arrive with the GPT-based models, which is a text language generation aspect. And if we stack the multiple encoders block of this particular architecture, we get bidirectional encoder, which is a BERT architecture, which it's a fantastic discoveries which are happening and able to contain solve a lot of the tasks that we have in front of us. With these advent of this architecture, now all these tasks are now getting we are able to generate the higher accuracies and as an outcome. For example, in conversational AI, usually an interaction between a consumer and the bot, the user and the bot, usually the intent is not identified at the first level of communication, the first thread of the communication. It is actually at the depth, in different layers we go in communication. There is a questions and answer, and apparently the right intent of a particular request is being identified from the user. So which means that the context has to be carried out to that level, and that's where this BERT, which I mentioned earlier, the architecture plays a great role. Another fantastic work which has been done on the automatic text summarization, wherein a large corpus of a text and the engine is able to derive the nuances and create a summary out of that text. This has been phenomenal. Sentiment analysis, we have been knowing that for a long, wherein outcome is probably we are looking at the positive, negative, and neutral side of the response, which a feedback from a customer. But I think the expectations are high. We wanted to have more towards the empathy for the customer as well, to know more from that. So it requires a multivariant outcome rather than the 2 or 3 distinct responses. And that's again, BERT plays a great role there. Fact checking, basically any text which you have written, is that what is it is factual, text entailment. And I mentioned about the machine translation also. It's all again, this transfer-based architecture is able to provide a higher BLUE score, which is higher accuracy of machine translation and at the lower compute. So all in all, I think we are knocking at the door, which have multi-myriad opportunities of opening up. For that matter, market intelligence, organization have the army of human beings who are actually researchers who are actually going through various geographies, looking at the local regulatory requirements, for that matter, integrated information flow of a supply chain, financial analysis, and all this is done by human beings or researchers manually. And if we give this complete context to NLP engine, and probably we are getting now results which are able to derive the actionable intelligence out of that, and even that correlating with what is there on the social media. This is helping in driving the businesses for better strategies as well. Last but not the least, the financial sector. There's a report from the Economist that it is believed that the branch-based models would be die by 2025. Some bankers believe that there's an extension. There's an extension for the high street banking, and financial institutions are creating a tech-enabled, inclusive ecosystem, and which is where the customer experience is a king here, driving through the self-servicing side, automation of the business processes, then probably accuracies in the business decisions which are being taken, for example, accuracy in the credit decisioning, and knowing the customer with empathy. So getting into that level. So further, and of course, further strengthening of our India stack, having a paving way for embedding finance. This is all where the text is involved there, and text is like everywhere. So if probably we can go to the GSTN network, get the real-time cash flows out of that, and then the decisions are taken on real time. That really increases the business viabilities as well as NLP looks to be a game changer. And for example, the conversational AI we have talked about, enhancing the customer service functions, helping users autonomously, which means they're self-serviced by doing the simple operations like making payments and managing refunds, tracking transactions, and even these going to aid for the fraud detection or anomalies, because we have the past experiences of the activities of the user which are done. Document summarization, again, there's a lot on non-standard financial documents which are there, and so NLP is going to be is giving giving a great results in all these areas, and helping in the business institutes. And what I see is, I think this is my last slide, which says if you look from a text, something like this, and maybe the NLP engine is going to predict something like this as an output. That's not far. I think with this I would like to end my talk, and thank you so much for patiently listening.
5 मिनट में अकाउंट सेटअप और ट्रेडिंग शुरू।
हाँ कर सकते हैं।
नहीं कर सकते।
लगी शर्त और हारा तो It's possible with CoinSwitch Kuber. Download करो और Bitcoin trading start करो. CoinSwitch Kuber. सिक्का चमकेगा.
Cryptocurrency is an unregulated digital asset, not a legal tender, and subject to market risks and price.
Where there is life, there is hope, there is meaning. But life has its downs as much as its ups. Life is about challenges. Life is about opportunities. Time for joy, time for celebration, and time to introspect. Thankfully, in every one of life's moments, and even beyond life itself, there's LIC. Where there is life, there's always LIC. Zindagi ke saath bhi, zindagi ke baad bhi.
Welcome to Fego, a pioneer in the world of intelligent open finance. With our full-stack open finance platform, we enable companies to understand their users' financial behavior across various use cases, making finance engaging and actionable. Fego's developer-friendly product stack helps clients with friction-free user onboarding and authentication using trusted account information, Connect and aggregate your users' banking transaction data from any source, either any of the account aggregators or directly from any core banking solution at flexible intervals. Enrich and categorize transaction data using machine learning algorithms to extract deep behavioral attributes of your users. Understand and act on real-time insights powered by your users' behavior for a variety of use cases ranging from lending, wealth, income verification, frauds, to even branding and marketing insights. Engage with your users by embedding our personal finance management SDK in your existing user-facing app to push positive financial habits and personalize financial insights to your users. If you are looking to engage or understand your user base's financial behavior to take informed decisions, Fago is your perfect partner. With the complete Fago suite, you can now capture what drives your users at every stage of their journey and use it to drive your growth. Plug into Fago and let us do the heavy lifting for you.